I'm really glad to be here. This is my second time when I'm presenting something on DevClub, and I'm really proud of this event, actually. And I hope my today's talk would be pretty interesting. Well, basically, what I will be talking about is the performance optimization in general. Of course, some of the words would be really familiar for you. And I'm not going to provide you some rocket science or something like this, but more like methodology or approach on how to build your system with a good shape and why it is really important for everyone, not for you as an engineer, but for business as well. And basically, what we have here is we have several critical things here. Impact on user experience, especially for the people who, for instance, clicking on a website or using the bank application and try to see what the state of money they have, and this information is refreshed for minutes, which is completely unacceptable. And bad user experience leads to, let's say, some problems with the business, some loss of money, and of course, impact to the engineers who did their work not really good. So this is also cost savings, especially if you are using cloud environment, and if you have your clusters or pipelines or anything else working slow, you need to pay more money for CPU, for storage, for everything, and actually that's a lot of money. And business also wants to have some savings on this. And of course, what are the real bottlenecks here is just 3 points: hardware, software, and network. Hardware, it really depends on what you have. If you have on-premise environment, of course, this is your own hardware, and it really depends on how much money you spend on it. For old environment, of course, it would be pretty slow CPU, not really enough memory, slow hardware, maybe some kind of not enough bandwidth for a network, like not a gigabit channels, but probably hundreds of megabits or something like this. And everything actually comes together and you get slow results. For the software, well, everyone knows that a lot of people are writing not really good code, especially people who are just starting to write some code. And of course, Hello World is pretty good example on how it works fast, but a lot of people try to apply their own thoughts and use not really optimal algorithms or approaches or technologies or even environment. So basically, every person learns how to write it better. And through the years, you got better experience, you got the more knowledge, you read more books, you just learn, and you can write your better code. Network, pretty same thing. One of the favorite tests on customer environment is actually try to copy pretty huge file to the server and back. For instance, let's say a movie, and just measure a speed of copying process using just a timer. And you will see the actual network bandwidth. And the reason is that one time we had a response from customer that something happens and all the server responses are pretty slow. And the reason is that they tried to use 100 megabits channel instead of the gigabit channel. And bandwidth was really not enough in this particular case, which is, let's say, which was not really good for us. Okay. Fundamentals of performance. That's really obvious thing as well. And by the way, if you have any questions or comments, just please go ahead and you can submit at any time. So there are 3 points here: latency, throughput, and of course bandwidth. Latency is actually just comparing to the restaurant is how much time restaurant requires to prepare your meal. Throughput is how many meals they can do at the certain time. And bandwidth is actually the biggest amount of meals that they have at the same time. So here is pretty obvious thing. If you have, let's say, pretty bad bandwidth, there will be no really good throughput, just because of not enough time, space, I don't know, size, whatever. And here we have just key metrics: CPU, memory, I/O, and response time. For the CPU, actually, on the previous presentation, you saw a lot of the examples of the hardware resources, of the CPU usage as well. And basically, CPU is the kind of corner case when you can see how heavy your system is. And if you will monitor the CPU usage, definitely you will get the more understanding on what is actually happening while your system is running. Pretty same thing for the memory. It is really important to know how much memory required for your solution, for your software, for anything. And if you can monitor as well the memory usage, you can plan the actual workload, and you can plan your scaling in terms of memory. Of course, right now, memory is not really something that is really expensive. There are a lot of environments with the terabytes of memory available, and they can be used for anything like data caching, like processes serving, just anything. But let's say 10 or 12 years ago, before the cloud era, we had a mostly on-premise environment. And in this particular case, both CPU and memory were kind of not really cheap things. And companies spent a lot of time on the hardware, which on premise. And the upgrade of this hardware was also not really easy thing. And the problem was actually how to utilize it normally. And for instance, when I was working for Oracle PSR team, we had a really interesting results, especially for the CPU usage when we tried to run, let's say, 10 pipelines in parallel on really, let's say, not really powerful environment. It was stuck for let's say, for an hours. Another interesting example was when we had a customer escalation in terms of the performance regarding the speed of the reports that they had. They tried to set up the UAT servers and tried to run one report on Oracle PSR. Everything was fine. When they tried to run two reports in parallel, system CPU utilization was grown to 60%. For the third report running in parallel, system just had 100 CPU utilization and just died. We spent about a month on trying to figure out what actually happens, especially if we didn't have any access to environment, only just the calls to the customer and some of the SAR report provided from the sandbox, which was really powerful. It was kind of most recent machine from Oracle with 200-something CPUs, with the terabyte of memory available, with huge of the disks running, just really powerful machine, but everything was slow. And the funniest thing is that after 1 month of, let's say, meetings and figuring out what's happened, customer said, well, guys, actually, we just created two virtual machines on this really powerful machine and allowed them to use just a single CPU per each. So you can imagine what's happened. It was a really funny thing, especially when we spent a lot of time on just figuring out it. Fortunately, Oracle said that they are not supporting such an environment, and we closed this ticket, but it was a kind of funny experience because you don't know what expect from people, let's say from the other side, from your customers, from other engineers. And for instance, there was another interesting case. In one Belarusian company, they built their own accounting software. And the problem is that this software was hanging for 10 seconds each time they click button save data. They tried to buy more powerful hardware. They just tried to increase memory. But when we took a look inside the code, we found that there was a wait loop for 10 seconds. Nobody knows how it get there, but anyway, it just took a lot of the resources on this particular case. Okay, so what you can do here? The most important thing is that you need to measure all your efforts. And actually, there is just one approach. Start measuring before you start optimizing anything. Just provide a kind of baseline and see the results that you have on an optimized system. Just taking it from scratch and run it and measure. For instance, when we got a new release for Oracle BI applications, that's an ETL from Oracle Business Suite to Oracle Data Warehouse, and executed the initial run, which was doing just a full load from the source database to the data warehouse. It took about 1 month to complete the full load. You can imagine, this is completely unacceptable. Just imagine that you buy something really expensive, like an expensive car, and it just provides you speed like a tractor or something like this, which is completely unacceptable. And we spent about 3 months of optimizing this initial run, and we made it running for 40 hours in total, which was really good result. But the first baseline was 1 month, and we just made it just 40 hours. And basically, there is another golden rule when you are starting to optimize. One change, one measure. Don't do a lot of changes at one time. If you need to change something, just change it at one place, then measure the impact. If it's good, okay, go ahead and do anything else. Just optimize other things. If not, you can reverse back, redo your work, and then measure it again. And what would happen, what would help you here is profilers, which allow to profile your code, just do the best work here. Of course, the dashboards that can monitor the CPU, the I/O, just anything you like, amount of users, response time, just a lot of the things, and provide it graphically and provide it, let's say, in almost real time. And you will see everything just on a screen, not just let's say, lines of code or messages, but you will see the graphics, which is more suitable in this particular case. And you can, and which is more important, you can get customer involved, especially if your customer just stands behind you and sees what's going on here. You can say, okay, guys, just relax. Here is the dashboard. Just your activity is to monitor this stuff and say me when the spike will be above this line. That's it. And customer feels involved into a process, and it let's say, keep them busy and do not disturb you while you are doing actually your work and optimize the system. Especially if this is somewhere on site and this is a really urgent activity. So, a really good example is identification of the slow queries here. Basically, last time when I've been here in DevClub, I was talking about the AWR, which is automatic workload repository in the Oracle database. This is a thing that actually samples system statistics by default once per hour, sampling just values like 100, 200, 300 of something. Like, for instance, amount of physical reads, physical writes, I don't know, logical reads, full table scans, a lot of statistics, really a lot of, more than 1,000 actually. And it's just samples. And if you will start to use deltas between samples, you can get the actual amount of the processes doing something, and you can compare it to prior states. And of course, you can, let's say, capture statistics for state when system is idle and when system has a kind of normal workload and spikes of workload. And you can compare it and grab the really valuable information of what's going on there. And of course, you can grab information about what the queries are running between those two samples. And you can grab the statistics on how much time it took to run the query, how much CPU it spent, how much physical I/O operations it did, how much logical operations it did. So a lot of the information. And basically, you can also provide it in a graphical mode, and you can also provide it in a tabular mode, saying that this is actually the thing that you need to pay attention. Well, another really important thing is code level optimization. On the previous presentation, you saw a lot of examples, but this is a really important thing. And talking about the optimization of the code, I'm not talking about the Java or C++, because let's say I'm not really specialist on these languages. I'm a specialist of working with the databases and working with the data integration. But basically, even using the ETL tools like Informatica or anything else, you can also apply bad algorithms or good algorithms. You can apply, let's say, loops somewhere inside the ETL process, which is not really good, because if you are working with the databases, you are working with the data sets and operating with the SQL mostly. And of course, once you are working with the SQL, you are not thinking about the loops itself. So you can also think about how to get rid of the loops, because loops are not really good things in this particular case. And basically, another point is, while you are running your ETL, you can apply a lot of the expressions inside of your data transformations. And those expressions can be pretty similar, but at one case, on the Informatica ETL tool, we found some of the pipelines were extremely slow because of the CPU, actually. And there were a lot of the computations performed for some of the transformation steps. And when we tried to dig into, we found that some of the fields were using almost the same expression. Let's say some calculations plus value of the field. When we figured out that we just had 20 or something like these copies of the same expression, we just placed this expression into variable and then started to reuse variable. And actually CPU usage dropped by 20% or something like this, just for this transformation, which was really interesting case because of, let's say, developer who did this pipeline didn't figure out actually what's happened and how to do a really good job here. We wrote a really good note for this particular case, and developers started to reuse it and started to analyze the code. And actually, next release of the Oracle BI applications was really successful, just for this small change. Another point is that it also important how to process your data. For instance, if you are trying to process your data in a small portions, like let's say 10,000 rows in a one batch, probably it would be worse a scenario even if you will try to use it. Because in this particular case, it's much wiser and much better to use, let's say, bigger sizes of batches, like 100 rows, 100,000 rows. Sorry, I'm really not good in numbers in English. Sometimes I just need to translate it in my head. So basically, the biggest size of the batch set sometimes is really more successful. And another point is, if you are writing your own ETL tool or your own ETL code, which is extracting data from something and then inserting it, sometimes it's really good not to process row one by one, like a lot of the applications doing, just pulling inserts into the target database. You can combine it as, let's say, in a huge batch, then surround it by begin and end words and send it to a database as a single command. And this would be much faster, actually, if you will do it in a single command then, rather than in a lot of the commands separately, even if you have just one commit at the end. So another really important point is the parallel operations. Of course, we have, let's say, environment with multiple CPUs, and we can use multiple threads. So it's really good thing if you can run your query with the parallel effects enabled, or parallelize your pipelines and, let's say, run it in 4 threads instead of 1, which will definitely optimize the speed of your ETL process. but it will also consume more CPU. It will also consume more memory, and I/O processes will be a bit higher. But at a certain point, if you figure out that you can run this process, and this is a really heavy process, which is really most important process in the whole of the sets of the pipelines you have, definitely you can do it. And you can use it, let's say, define the monopoly of this process. For instance, once we tried to optimize really heavy query on the BI server, which was running on Oracle database, specifically on Exadata environment. And the problem was even with the parallel operations, it was extremely slow. And the reason actually was not in the parallel operations. The reason was with the ineffective query which BI server actually generated. We spent about 10 days on figuring out how to optimize this, and just, let's say, applied simple logic. We just replaced the query by this separate view and forced BI server to use this view instead of the query generated by it. But we managed, let's say, 2 or 3 hours running report to run within 2 minutes by just doing, let's say, not a hacking, but breaking a system. So basically, everything is in your hands, and you can do whatever you like with the system, especially if you know when to use it, what to do, and how to apply it. But parallel stuff is really good one, especially if you are trying to aggregate data and you can use parallel queries, and you will see definitely it will work much faster than the serial query. Well, as I already said, I'll be talking about really obvious things. But anyway, if you will put it into the practice and if you will start to play with it, well, it will bring you a new experience. You will get the new knowledge, especially if you never tried to play it with the parallel systems. Of course, most modern systems are using a lot of the parallel processes, especially for distributed environments. When like Hadoop stuff, like MapReduce stuff, which is running on multiple nodes, doing a lot of things on parallel and providing the results to you much faster than, let's say, any other environment, which is doing the same work on a single node. Okay, so next thing is the system level optimization. Of course, if you have an ability to work with your environment, and if you have, for instance, DBA skills, or you can work closely with DBA, you can also read a lot of the books about the memory management for servers, not only for database servers, but for application servers, just for anything. You can spend a lot of time of working with a specialist who is administrating this software. And you can also play with the settings for this software. For instance, for a database, it's really important to optimize the memory usage and to set up the configuration for the memory. For Oracle databases, let's say there are more than 1,000 parameters for a database, which can be tuned, tweaked, and they will change behavior of the database completely. And of course, most of them are memory parameters. Nowadays, Oracle actually did, let's say, pretty simple thing. It allows you just to set up the target value for the memory, which is allowed to use by a server, and let's say get rid of the database administrator work in terms of memory tuning and do it automatically. Of course, this is a good solution, but it is pretty close to, for instance, manual gear in your car or automatic. So basically, either you can let system to optimize your memory or how your car is actually rolling, or you can shift your gears manually and do it more probably better. But anyway, this is a really interesting moment here, because once you have this experience, you will start to use it. So Another interesting point is the garbage collection, especially for the applications that developers are writing. This is a really important thing if you start to clear your garbage, especially just resetting the variables values to nulls, which will allow you to free a lot of memory, especially if it's not used. And there are a lot of examples when such a memories were using, let's say, megabytes of the data stored there, like JSON structures, like XMLs, and let's say we're staying with this value for a whole session. Let's say session was using a lot of the memory. For instance, you can see it in the Chrome browser. If you check out how much memory Chrome browser tabs are using, you will be really surprised, especially if it says like a gigabytes or something like this. And once you clear your garbage, you will see that memory usage will be much lower than actually it was before. So for I/O optimization, it's a really interesting thing. Start to use batch calls instead of the separate calls. As I already told you, separate insert statements instead of the one huge batch with the, let's say, 1,000 insert statements, which will be running much faster. And of course, you can combine those batches into the separate requests and run them in parallel using the different connections to a database. And for instance, running your pipelines in parallel, doing, let's say, same job, but with the different data sets by writing to the same table or data structure. But anyway, this would be much faster than just using one statement by one. There is an interesting example when we built a system for the financials, for the stock exchange tracking software. We were using Kafka for the streaming the data to the database, and we were using microservices as a solution that will be getting the batches from the Kafka, let's say streaming from the Kafka, and send batches to the database. There was an issue that we couldn't get into the requirement to insert 300,000 rows into the database within 1 second. And while we created a test, database was able to actually accept this amount of data and insert this data for less than 1 second, something like half of a second. But for some reason, it never happened while we tried to test our solution. I joined this project on the phase when projects tried to start the performance optimization for the solution. And when we dig into the code, we found that every row from the streaming tried to be inserted into the database separately by separate code. So you can imagine that microservice had to get the connection from the connection pool, then insert statement, then give connection back. And actually, when we combined all the batch into the huge one set and send it to the database, we managed to do it in something like 1.1 seconds. I'll tell you later what's happened actually there, but anyway, batching sometimes is a really savior in our case, especially if we're trying to, let's say, reload a lot of the data from one pocket to another. Well, another point is the database optimization. It is not related to the memory tuning or storage tuning. It also meaning the database structures tuning. For instance, if you have one huge table for everything, especially if you are running your ETL and you are writing a lot of the strings instead of the numbers, dates, and stuff like that, of course, this table will be really huge in size. It will have a lot of the columns, which is not really appropriate. Of course, it can be probably fastest solution in terms of while you're loading your data. For instance, same process of streaming is just pulling the data from the streaming process to the database directly, even using a batches, but writing it just as it is, everything is a stream. But when you start to search for something in this table, it will take a lot of time just because of the huge size of the table, and the database would need to read a lot of the blocks from the disk and figure out what's stored there. And of course, if you have everything in string, you need to parse it, convert it to a different data type, or probably apply some business logic to figure out, for instance, lookup values or something like this. And everything will slow it down just because of the I/O, because of the additional CPU computations to be performed. And in this particular case, it's really important to combine optimization of the code of the application and the code of the database as well, and probably make agreement with the application developers not to use the strings only, but also add them to use, let's say, some kind of lookups or anything else that can convert, for instance, codes that provided in a text format, like a string, to a numeric value, or parse data by application, which probably would be faster than database will do it with the text. And another point is the indexes that probably can be applied on top of your table just to speed up the queries. But if you need to provide a solution that will write your streaming data pretty fast, probably indexes would be a really bad thing that you will create, because database would need some time to build the indexes while you're inserting your data, and this will slow down the information. And in this particular case, what you can do is just write data into the database, which has just one constraint enabled, primary key, that will allow you to uniquely identify the row. No checks, no indexes for the performance query, no foreign keys, no nothing. Just one primary key. And this will be probably the fastest solution that you will create. Well, another point is the caching layer. Of course, if it is possible to cache your data, that it is great, especially if you are running your queries which are short. Let's say for the OLTP systems, for transactional systems, one query retrieves not really much data. And for instance, your bank application. It knows your cards, it knows your accounts, everything. And you are not waiting for, let's say, 10 seconds or even 5 seconds. Sometimes it requires just 1 second to refresh your screen and show all your balances and stuff like that. And basically, each time you are using your bank application, you are querying a database. And this data is cached into the memory, and let's say, if you are accessing this information more frequently, this data will be kept in the database for a longer time. And basically, administrators or application administrators sometimes are using this feature, and let's say, running specific queries to load some important tables into the database memory and keep them there, just to be able to improve the speed of the queries, not only for OLTP, but for also DSS solutions. Okay, so regarding the scalability in architecture, well, there were two scenarios, like horizontal or vertical scaling. Vertical scaling, well, this is what we had, let's say, 15 years ago, in the era of the software giants like Microsoft, Oracle, just before the clouds, when a lot of the companies had on-premise software, hardware, their own data centers, and basically, in case if you would need more powerful server, you just the only thing that you need just to buy more CPU, more disks, more memory, which is vertical scaling. But every time it is getting more expensive and expensive. For the horizontal, you can have a bunch of the cheapest computers, like developers' desktop, and organize it into the cluster and start using it as a distributed environment. For instance, Hadoop environment with the big data, which can use just cheapest hardware, actually, but organize it into really huge clusters like, I don't know, 1,000 nodes, and you can load any information there, run your transformations, like run your aggregations, and get the results much better than on vertically scaled environments, just because you have a lot of the nodes, you have a lot of the parallel operations, and much cheaper environments in this particular case. And this is one of the other optimizations, like money optimization. And of course, if you will propose business to spend less money on the hardware, but let's say similar results on the performance, business will accept it as well. So another thing is microservices, which appeared not recently, but some time ago. And this is really good thing for distributed environment, especially if you are using a lot of the, let's say, nodes on your farm or on your cluster. And definitely load balancing here will also help you to spread the workload for your environment, for your cluster, by different types of algorithms like round robin or something similar like hashing. Basically, this will also allow you to optimize your, let's say, data storage. Not the data storage, but let's say how to process your data and keep it in your data storage, and in a more efficient way, and distribute it across the huge cluster on a cheap hardware, and get the results with the same time frame as really powerful hardware. Last example is the Oracle Exadata. I really like this machine. This is a kind of, let's say, just imagine Oracle database server is a train. Exadata is the same train, but this is a Ferrari train. It can hold same data, but it can process it much faster, but it is way expensive. You need to pay a lot of money, but you can get cheaper solution, like, for instance, Amazon Cloud with Redshift, and get pretty similar results for, let's say, less money on licensing, on anything else. Of course, this is not an Oracle database, which is, let's say, the best database probably in the world. That's my opinion. You can doubt on that. But I always say that there is no God except Allah. There is no database except Oracle. So basically, you can optimize not only your hardware, software, and processes, but you can optimize your money here. And of course, cloud-native optimization is a really good point here, especially if you don't need to pay for the hardware by yourself, but you can, let's say, order it from cloud providers like Amazon, like Microsoft or Google, and start using it there. And actually, you can also calculate how much hardware you need, how much servers, how much memory, how much everything, and how much time actually you need to process it. And you can define also your strategy, what you are paying for storage, for CPU, or for anything else. And of course, this is also the good optimization, especially if you don't need to store your hardware somewhere anymore. You don't need this data center on your, to keep it on your budget and provide the upgrades, keep, let's say, storage safe, a lot of things. So basically, this is a really good point here to optimize not only costs, but also the responsibility for the environment, especially if provider promises you that your data will be safe, that everything will be up and running, and everything will be backed up and restored in maybe not minutes, but in hours in case of any failure. And they will also pay you a lot for any failures that related to their problems, or data leaks or anything else. So basically, you will be on a safe side in this particular case. Okay, so real-world examples. As I already told, we tried to build a solution for the financial company. And there was an interesting case when we started to observe the Java code for one of the microservices, especially the part which was responsible for inserting data into the database. It was really funny to figure out that for one row, it was required to create 4 calls to the database. First one to get the temporary value for the primary key. Second one is to update the row. First one is to insert the row. Second one to get the value for the temporary primary key. Next one to update this inserted row with the temporary primary key. Then get another primary key value and update this row with the final primary key value. Just imagine how much operations it took. And when we started to profile the code and started to create the performance tests, we figured out that the best scenario that we had was just about 1.1 second per 100K rows inserts. When we moved this huge ugly part of the 4 statements per 1 insert to the storage procedure, actually, doing not the same thing, but let's say doing same insert without any additional calls to the database within the storage procedure, everything became really normal. But the problem is that we had to process too many data, and it still had to be 100,000 calls to the database because we had this really huge amount of streaming data coming. So what we did, we just converted everything to the JSON and provided this JSON as a parameter to the storage procedure and process it within the storage procedure, and managed to make the insert of the 1000K rows within 0.7 seconds, which was really okay for us in this particular time. But another problem is why JSON? We had to use a database called Iris database, if you ever heard about it. Probably you've heard a thing called cache database. Right now it's Iris data platform. They are on cloud. Let's say cache database, not cache, cache. They had a French name. It was kind of popular in 2000s because it was completely object database. But believe me, there are no worse nightmare than the object database, especially if you try to build the relations between objects, and then you can and then you have SQLs applied on top of the objects. That's a really huge nightmare, especially if you try to reference and deference the column names through the object properties. So basically, the interesting thing was that they built something, I would call it some kind of mix of the hedgehog and elephant, which was running pretty fast on inserts, but procedures were not able to accept more than 128 parameters at all. And we had a huge table with something like 300 columns to insert. So this was the reason why we had to pass the JSON as a single parameter and then parse it in this storage procedure. But anyway, it was faster than to use the inserts from the Java microservice. Well, another point that I really saw and also took a part on it is the performance issue with one of the ETL processes in Royal Bank of Scotland. When they had an ETL process running for more than 24 hours, by, let's say, running the hierarchy query on the source database and trying to insert it into the target. And the problem is that Oracle database unfortunately has bugs. And one of those bugs are related to the hierarchy queries. If you have any experience working with the Oracle databases, you're probably aware of the connect by statements, which is similar to recursive CTE expressions on the SQL Server, which appears much more, let's say, not really long ago, but Oracle hierarchy query, the connect by statement, was available since Oracle 7 version, which was released somewhere at the late 90s. But this statement had a bug, and when we tried to test it, we figured out that on Oracle 11.2, we had result of 2 million rows in the output, while the source table had just 400k rows, which was really strange. It was running for 22 hours. When we tried to rewrite it using the common table expressions, it started to produce not 2 million rows, but something like twice less, and it was running for 18 hours. When we tried to convert it to the recursive CTE expression, it was running just for 2 hours and produced something like 400k rows in the hierarchy. When we tried to compare the data sets generated, we just figured out that first and second tables had absolutely the same data, but with a lot of the duplicates. And final solution with the recursive CTE had no duplicates at all, had complete hierarchy built, but actually this allowed us to provide a solution to the Royal Bank of Scotland and improve the performance of the ETL process and dropped it down to something like 2 hours, which was really good result for us, especially if we closed it just for 2 days. So for the lessons learned, what actually I would like to say, it is really interesting thing to work with the performance and think about the performance and start to analyze everything in terms of the performance, especially if you know that you can do it better, and if you start to do it, you will get a really interesting experience and you will figure out that everything can work faster. And again, if you know a bit more, you can start to apply your knowledge to your daily processes, not only in agile manner, but also with the code you are writing, with the understanding of the systems, how it works, and with the puzzles that you are trying to solve, and just get everything together and see that it is working much faster than it was before. Okay, questions? Well, I have 2 gems here, but I'm not sure if I know how to enable hidden slides. Just find it.
I've got a question.
Sure.
You gave an example of moving data to a data warehouse, and it took like a month, roughly, if I remember correctly.
Yes.
And you sped it up. What was the cause of such a long duration of transferring the data? What was the fix or the issue?
Just imagine that Oracle is a huge corporation. It has a lot of the products developed, and basically ETL from the Oracle EBS to Oracle Data Warehouse contains a lot of the modules like financials, human resources, manufacturing, healthcare, just a lot of things. If you are running your ETL, which is completely unoptimized, it has, let's say, statements somehow combined on a level of the ETL tools. Like you have cubicles with the tables, you have the connections defined between, you have expressions applied for the output columns, you have probably some logic applied, like summarization, aggregation, whatever. And basically, Informatica defines it on its own dialect of the SQL language. And once you have it generated, and you also don't have, let's say, defined things like memory, amount of records to process in one batch, you have, let's say, a default system. And once you have a default system, you are running it and you get just default result as it is, especially if you are trying to test it on a real production environment, not environment, but volumes. We had a scraped database with the real production data, but completely anonymized, and all the numeric values were hidden and shuffled. So basically, first run was really taking a month just to complete it. And once we saw something really slow, we just stopped it in the middle of the process, like especially if you started the pipeline at the morning and next day when you come to your office, you see it's still running, of course, you can stop it and just start to think what's wrong there. So initially it took about a month. Fortunately, we didn't have any schedule. That was probably my favorite project when we had no schedule. We had just, let's say, target, guys, just do something. Any other questions, please? Yeah, please go ahead.
What is your favorite tool for performance testing?
Great. Basically, I prefer logs. Why logs? Because if you're developing your own software, the best thing you can do is to log everything. Of course, with different levels of logging. Like default logging with the critical information, or logging with some information which is just showing that the process is running, and of course the debug information. Once you have an ability to provide the debug information for every step you are executing in the application, especially when you start to execute something, when you complete to execute something. Of course, if you can also provide information about the rows processed or batches processed with the amount of rows per batch processed, you can build a dashboard, or you can read this information and you can, for instance, calculate metric called row per second, which means, for instance, if you have 100K rows processed within 3 seconds, you have two timestamps. First one, I just started to write it. Next one, completed to write first 100K rows. Then you are starting to process next 100K rows, and next and next and next. So you can calculate delta between steps and calculate time spent on inserting this amount of rows into the database. You can build a chart and figure out what actually is wrong and what actually is right. If it's good or if it's bad. If your capacity and bandwidth are good for this amount of data, probably you can increase the size of batch or decrease it and measure the speed again, and you will see all the detailed information. So logging is probably most valuable thing, especially if you want to dig into. Of course, next part is any type of the dashboards. Even Kafka can provide you a lot of the information with the dashboards, because they have a lot of the plugins working with the databases, streams, just a lot of the things. So it really depends on, let's say, license cost. But you can also create your own tool. My first tool that I've created myself is the Perl parsing script, which was parsing the Informatica logs and generated the Excel dashboards. Let's say Excel files with the dashboards, with the graphics that showed me rows per second information and something else. I don't remember it. But let's say it was my first approach. Later on, I just met such a things like JMeter, which was completely free for the performance tests. It's a really good thing. I would suggest you should start to use it for the profiling, for the performance test executions, and for the statistics gathering. Any other questions, please? Yes, please.
You mentioned two things. One was the batching of the records before inserting them into the database, and the second, the cache. So this actually brings two more challenges. First one, in the batching, this is about the data integrity, how to guarantee that, and in cache, so how you just cope with the cache invalidation.
Well, thank you for the question. It's really interesting. Well, once you are inserting data, probably it will not be in the cache. If you want it to be in the cache, you need to read it after insert. But before you read it, you need to provide a commit, because once it's not committed, it will be, let's say, dirty data, and it will be completely invalidated at any time, especially if you're issuing rollback. But rollback is also really expensive information, especially in terms of the database I/O. So database would require much more time to roll back all your huge transactions here. So once you are batching it, you can insert data much faster than actually per single row. You can measure it by inserting in the loop or just sending one huge big statement, like for PL SQL or Transact SQL code, and you will see the actual results. But once you get the data inserted, if you want it to be cached, you need to read it. And each time you read it, it will be a committed version of the database in the cache. In case if you will need to modify it, let's say modification will not pass into the cache until you commit it and reread it again. Any other questions, please?
I have a question.
Sure.
What is your personal opinion on cloud services versus like your own hosted? Like, which you think is better, or you have some preference?
It really depends. If you are a bank, then certainly you need to provide security. And mostly banks are not trying to keep their really sensitive data somewhere in the cloud. They keep data on premise. But I'm not sure, let's say, time changes everything, and probably somewhere in the future everything would be on the cloud, because in this particular case you would need to support it. And personally, I'm okay with the clouds. And you know what I like, actually? Before the clouds, I had to keep my database server locally on my laptop. I had to keep a lot of the software on my laptop, just a lot of the stuff. Right now, I have the VDI client, which connects somewhere to the virtual machine, which has an access to the client network. And I have all the software licenses and installed there. Of course, there are some limitations. For instance, if I really like something personal, like Ultra-Edit text editor, I can't install it there just because of the some issues. And for instance, customer just doesn't allow to install any custom software. But anyway, in this particular case, I don't need to keep a lot of the software installed on my laptop. So I am not using it, let's say, I'm not loading CPU for 100%, and everything works much faster. And actually, for me, it's more, I like this setup, actually. Because the only thing I need is the client connection, that's it. And personally, I really like the solution because I don't need VPN. I don't need to subscribe a lot of the papers and subscribe the non-disclosure agreements and stuff like that. You got your client, you are inside the client network, everything's fine, everything is secure. But for on-premise, like in case with the banks, you need to go to the office. Nowadays, I don't like to go to the office. I like to work from home. Because I can see that in my pants and t-shirt without having a tie on and stuff like that. And grab my coffee anytime I need. The only bad thing is that I need to pay for this coffee. Any other question, please? So I have two hidden gems here. First one regarding the parallel work. You know why parallel is better. And the next one is actually my favorite Linux world joke. Actually, my wife, she is a school teacher, but she knows this joke, and she obeyed this comment, actually. But there is another side that I obey this comment as well. And when she said, "Suda, make me give me money," I have to obey. Okay, that's it. Thank you very much.